Imagine a universe alive with motion, a vast orchestra where every star hums its own melody, every planet spins in rhythm, and every moon dances in silent grace. This cosmic ballet stretches across billions of light years, a tapestry woven with light, gravity, and mystery. Yet, amidst this grandeur, one enigma stands apart, whispering questions that have haunted humanity for centuries. Worlds beyond our own, exoplanets, drifting in the shadows of distant stars. These celestial wanderers, unseen by the naked eye, hold secrets that could redefine our place in the cosmos. Among them, a single world, Arendor Sea, beckons with a promise so tantalizing it feels like a dream, a planet so akin to Earth it might be its mirror, yet cloaked in riddles we are only beginning to unravel. Picture yourself standing on the edge of infinity, your gaze sweeping across the Milky Way, a galaxy teeming with over 1 trillion worlds. Each one is unique, a story etched in stone, gas, or ice. If you could gather these exoplanets, each no larger than a marble in your mind's eye, their collective mass would dwarf the tallest mountains, filling valleys and canyons with a cascade of cosmic jewels. Among these, roughly 1 in every 5 bears traits so eerily similar to Earth's: rocky surfaces, stable orbits, and atmospheres that might cradle life, that they spark a question. Could one of these be a second home? Arendor Sea, discovered in 2023, is one such world, orbiting a dim red star just 5.1 light-years from our Sun. Its proximity is staggering. If you could travel at the speed of light, you'd arrive in just over 5 years, a journey shorter than a child's passage through elementary school. This exoplanet, nestled in the habitable zone of its star, Arendor Prime, exists in a delicate balance. Not too hot, not too cold, but just right for liquid water to pool in vast oceans or trickle through alien riverbeds. Imagine standing on its surface, where the sky glows with a faint crimson hue, the star a constant ember overhead. A day on Arendor Sea stretches for 14 Earth days, with sunrises that linger like a painter's masterpiece, casting long shadows across landscapes that might mirror our own deserts, forests, or seas. But what makes this world so compelling isn't just its Earth-like traits. It's the possibility that it holds more than rock and water, perhaps the faint pulse of life, or even the echo of something intelligent. To peer into this distant realm, we turn to a marvel of human ingenuity, the James Webb Space Telescope, a sentinel in the void that has transformed our view of the universe. Its golden mirror, spanning 6.5 meters, captures light that has journeyed for billions of years, faint whispers from stars born when the universe was young. Unlike its predecessor, Hubble, which dazzled us with images of nebulae and galaxies, the JWST is a cosmic detective, equipped with instruments that don't just see, they dissect. Its infrared spectrometers can tease apart the light reflected by a planet's atmosphere, revealing the chemical fingerprints of water vapor, methane, or even oxygen. These are the building blocks of life as we know it, and the JWST can detect them from light years away, offering clues about worlds we may never touch. Arendor Sea's story begins with its star, a red dwarf far smaller and cooler than our Sun. Red dwarfs are the most common stars in the galaxy, yet their planets are notoriously hard to study. Their faint light makes traditional observation tricky, but the JWST thrives in this challenge. By analyzing the starlight that filters through Arendor Sea's atmosphere during a transit, when the planet passes in front of its star, scientists can map its composition. Early data suggests an atmosphere rich in nitrogen and carbon dioxide, with tantalizing hints of water vapor. Could this be a world with clouds drifting over alien seas? Or does its surface harbor deserts sculpted by winds we can scarcely imagine? The JWST doesn't just show us a dot in the sky. It paints a picture of a world that feels within reach, yet remains profoundly alien. What sets Arendor Sea apart is its orbit. Positioned in the habitable zone, it receives just enough stellar energy to sustain liquid water, a key ingredient for life. But its 14-day rotation introduces quirks that challenge our understanding of habitability. On Earth, Our 24-hour cycle shapes everything from sleep patterns to ecosystems. On Arendor Sea, a single day could disrupt those rhythms entirely. Imagine a world where dawn creeps over the horizon for hours, bathing the landscape in a glow that lasts for days. Plants, if they exist, might evolve to track the slow-moving star, their leaves tilting in a languid dance. Animals, if they roam, might adapt to cycles of light and dark that stretch our imagination. How would life adapt to such a world? Would it resemble Earth's, or would it be something entirely new? The JWST's ability to probe these questions lies in its precision. Its infrared detectors can measure temperature variations across a planet's surface, revealing whether Arendor Sea has seasons, storms, or even volcanic activity. By studying the light reflected from its surface, scientists can infer whether it's covered in oceans, ice, or rock. One recent observation hinted at a reflective patch, possibly a vast ocean glinting under starlight. But the data is incomplete, a puzzle with missing pieces. Each observation builds on the last, slowly unveiling a world that might hold answers to humanity's oldest question. Are we alone? The search for life isn't just about finding water or oxygen. It's about chasing anomalies, signals that don't fit the patterns of a lifeless world. In 2024, the JWST detected something extraordinary from Arendor Sea, a faint, rhythmic pulse in the radio spectrum, unlike anything produced by natural processes like stellar flares or auroras. Scientists dubbed it a potential technosignature, a term that sends shivers through the astronomical community. For a fleeting moment, the signal seemed structured, almost deliberate, as if crafted by minds we cannot yet comprehend. Then, as quickly as it appeared, it vanished, leaving only questions in its wake. Was it a glitch in the telescope's instruments? A cosmic coincidence? Or something more? A beacon from a civilization reaching across the stars? This mystery drives the next phase of exploration. Researchers at institutions like MIT and Oxford are now using the JWST to hunt for signs of artificial activity. They are looking for light pollution, not unlike the glow of Earth cities visible from space. Imagine a distant world illuminated by the soft radiance of an alien metropolis, its energy spilling into the cosmos. The JWST's sensitivity allows it to detect such faint signals, even from 5.1 light-years away. If Arendor Sea harbors intelligent life, its cities might shine in wavelengths invisible to the human eye, but not to the JWST's infrared gaze. This is no longer science fiction. It's a possibility we can test. The implications are staggering. If Arendor Sea hosts life, even microbial, it would suggest that the universe is teeming with biology. If it hosts intelligent life, it could rewrite our understanding of existence. The JWST is uniquely suited to this task, not just because of its mirror or its instruments, but because of its position in space. Orbiting 1,000,000 miles from Earth, far from the interference of our atmosphere, it operates in near-perfect silence, capturing light untainted by earthly noise. Its coronagraph, a device that blocks a star's glare, allows it to focus on the faint glow of planets like Arendor Sea, revealing details that ground-based telescopes could never see. But Arendor Sea is just one piece of a larger puzzle. The Milky Way is home to billions of stars, each potentially orbited by worlds that could harbor life. The JWST is systematically studying dozens of exoplanets, from gas giants larger than Jupiter to rocky worlds smaller than Earth. Each observation adds to a growing catalog of possibilities. Some planets, like those in the TRAPPIST-1 system, orbit in tight clusters, their atmospheres mingling as they pass in front of their star. Others, like Arendor Sea, stand alone, their isolation making them both harder and more intriguing to study. The JWST's ability to analyze these worlds in tandem builds a picture of the galaxy's diversity, a mosaic of environments that challenge our assumptions about where life can thrive. Consider the scale of this endeavor. The Milky Way spans 100,000 light-years, its spiral arms cradling stars of every type: red dwarfs, yellow suns, blue giants. If even a fraction of these stars host habitable planets, The number of potential homes for life is staggering. To visualize this, imagine each star as a single grain of salt. Spread them across a beach, and you need a coastline stretching from one continent to another to contain them. Now imagine that 1 in 5 of those grains represents a planet with Earth-like traits. The odds of finding life suddenly seem less remote, yet the challenge remains immense. Each planet is a needle in a cosmic haystack, and the JWST is our tool for finding them. The telescope's power lies in its ability to see beyond the visible. Infrared light, invisible to our eyes, carries secret from the universe's earliest days. When a star forms, it's shrouded in dust that blocks visible light, but the JWST's infrared sensors pierce this veil, revealing the birthplaces of stars and planets. For exoplanets like Arendor Sea, this capability is crucial. Red dwarfs emit most of their energy in infrared, making them ideal targets for the JWST. By studying the light that passes through a planet's atmosphere, the telescope can detect molecules like methane, which on Earth is often produced by living organisms. A strong methane signal from Arendor Sea could be a clue, not proof, but a hint that life exists there. Yet, the search for life is fraught with challenges. Arendor Sea's star, like all red dwarfs, is prone to flares that could strip a planet's atmosphere, rendering it barren. The JWST's data suggests Arendor Sea has retained a thick atmosphere, possibly due to a strong magnetic field, but the details are murky. A planet's habitability depends on countless factors: its distance from its star, its geological activity, its ability to hold on to water. Even if Arendor Sea has oceans, they might be locked beneath ice or boiled away by stellar flares. The JWST spectrometers are working overtime to resolve these questions, analyzing light for signs of water vapor, carbon dioxide, or even ozone, a molecule that, on Earth, shields life from harmful radiation. The possibility of life on Arendor Sea raises profound questions. If life exists there, is it like ours, carbon-based, water-dependent? Or could it be something entirely different, built on chemistry we can't yet imagine? The JWST's ability to detect organic molecules offers a starting point. On Earth, organic compounds like amino acids are the building blocks of life. If similar molecules exist on Arendor Sea, it could suggest that the seeds of life are universal, scattered across the cosmos by the same processes that formed our planet. But life is only half the equation. Intelligence is the other. The fleeting signal from Arendor Sea, that potential technosignature, lingers in the minds of scientists. It wasn't just a random burst of energy. It had a pattern, a rhythm that hinted at purpose. The JWST's radio receivers, though not its primary tool, picked up the signal during a routine observation. Researchers are now designing follow-up studies, aiming the telescope's instruments at Arendor Sea for longer periods, hoping to catch another glimpse of the signal. If it reappears, it could be the most significant discovery in human history. If it doesn't, it might remain a tantalizing mystery, a reminder of how much we have yet to learn. The search for intelligence is a new frontier for the JWST. Beyond atmospheric analysis, scientists are exploring ways to detect artificial structures or energy emissions. On Earth, our cities glow with light that's visible from space, a signature of our presence. If Arendor Sea has inhabitants, their technology might leave similar traces, perhaps in the form of infrared emissions from power plants or communication signals leaking into space. The JWST's sensitivity makes it possible to detect such faint signals, but the challenge is distinguishing them from natural phenomena. A star's flare, a planet's aurora, or even a passing comet could mimic the signs of technology. The telescope spectrometers are key here, breaking down light into its component wavelengths to reveal patterns that nature rarely produces. This pursuit isn't just about Arendor Sea. It's about the bigger picture, the possibility that the universe is alive with civilizations. The Drake equation, a formula used to estimate the number of communicative civilizations in our galaxy, suggests that even if only a tiny fraction of planets host intelligent life, there could be thousands, perhaps millions, of such worlds. The JWST is our best tool yet for testing this idea. By studying exoplanets in unprecedented detail, it's helping us refine the equation's variables. The number of habitable planets, the likelihood of life emerging, the odds of intelligence evolving. Each observation narrows the gap between speculation and evidence. Arendor Sea's proximity makes it a prime target, but it's not alone. The JWST is studying dozens of other exoplanets, each with its own story. Some, like those in the Kepler 442 system, are larger than Earth, with thicker atmospheres that might trap heat more effectively. Others, like the planets orbiting Gliese 581, are older, their surfaces potentially scarred by eons of geological activity. The telescope's data is revealing a spectrum of possibilities, from worlds shrouded in toxic gases to those with clear skies and sparkling oceans. Each planet adds a chapter to the story of our galaxy, a narrative that's still being written. The JWST's role in this story can't be overstated. Its predecessors, like Hubble and Spitzer, laid the groundwork, but the JWST is a leap forward. Its mirror, composed of 18 hexagonal segments, is a work of art as much as science, coated in gold to maximize its sensitivity to infrared light. Its instruments, cooled to near absolute zero, operate with a precision that borders on miraculous. The telescope's ability to stare at a single point in the sky for days, collecting photons one by one, allows it to build images and spectra of unparalleled clarity. For a planet like Arendor Sea, this means we can study not just its atmosphere, but its surface features, its weather patterns, its potential for life.